Hi everyone, in this video I'm going to be going over the answers and how to solve the problems from your Unit 0 review. So for this one, it's asking which sets to which the value -1 and 4/9 belongs to. Already we know that it's a fraction, so that fractions belong to rational numbers. In a previous video, we mentioned how in the denominator, if it has a 9, then it has a line. So we know that this repeats if it was in decimal form, but we don't need to worry about doing that. What we do know is that it is a rational number. And then the next category under rational numbers are integers, and we know that this is not an integer because it would not fall on the number line. So we are good with just rational, and so then we are considering it a part of the real number system. All right, so this is slide 2, and in slide 2 we're doing what we did in slide 1 but with a different value. This one has a negative sign outside of the square root. This is a square root, not a cube root, and so we are good. We know that there's a chance we could get a rational number. If it was inside the square root, then we know that we would get an imaginary number, so it wouldn't be a part of the real number system. But 144 is a perfect square, and so when you plug that into your calculator, the square root of 144 is going to give you 12, and then add that negative sign afterwards, and go ahead and put your denominator. When you simplify, you get -3. Okay, and now let's look at our sets that we have. So we know that this is a rational number because it ends. We also know that it is an integer because it falls on the number line. It is not a whole number because it's not 0 and up, and then it's not a natural number, not a counting number. Which property justifies the statement below? If 7k equals 14, then 14 equals 7k. Okay, so for this statement, you see the words if and then, and you just see if and then, you don't see and. So this is the symmetric property. So whenever you see just if and then you're dealing with that property. If you also have and in there, then that's going to be the transitive property. All right, on this slide, we need to simplify this expression. So we're going to use the order of operations. I'm going to write GEMDAS off to the side. Hopefully you did that as well. Okay, so first we need to deal with grouping. Absolute value is a part of grouping as well as the parentheses that we have. So I'm going to copy everything else down and work with absolute value first. Okay, so I have 40/5, and that would simplify to 8, and I have a negative inside of that absolute value bars. So the absolute value of -8 is +8. And then inside my parentheses, I have 7 minus 12. So when I do 7 minus 12, I am going to get -5. And then I got to keep my exponent. All right, next I'm going to work with my exponents. So when I do 3 to the 4th power, I get 81. I'm going to write this in red. So this is kind of like my second step that I'm doing. So 81, and copy everything else down. And then I have -5 squared. A negative times a negative gives me a positive. And so as my answer, I'm going to get 25 for that. All right, now I have to subtract from left to right. I'm going to do this now in green. So when I subtract 8 from 81, I'm going to get 73. And now when I do 73 minus 25, I am going to get 48. So 48 is your final answer. All right, I need to simplify this expression. First, I need to distribute. So what I'm going to do is I'm going to give that -4 away to the 3a and then also give it to the +2. So when I do that, I get -12a, and then I'm doing a -4 times a +2, and that's going to give me a -8. So I can write that as -12a minus 8, and that's all I can do because I don't have like terms, so I can't simplify anymore. All right, so here we're going to simplify. Real quickly before we simplify, I'm gonna add some ones in here. It might make your life a little easier to do that. So we can add a 1 in front of this sign because that's kind of like what we are distributing into the numbers inside the parentheses. And then we can also add a 1 to be the coefficient of that x in the front. Okay, so now that we did that, we can go ahead and distribute this -1 to both the +1 and the 4x. So then we have -1 minus 4x, and go ahead and copy everything else down. All right, so now we need to combine like terms, and I'm going to do this by highlighting these and color coding them just a little bit, so we'll just hold tight. Okay, so I'm gonna do my x's in blue, so I'm coloring these in blue, and then I'm gonna do my constants in green. Okay, and then the proper form of writing this is making sure that you write the variables first. So we have -4x and a -1x, and those together, those like terms combined gives me -5x, and then I have +13 and a -1, and when I combine those together, I get +12. So that is this expression simplified, -5x plus 12. All right, I'm going to translate 3 times, I know that's going to be multiplication, the sum, so I'm adding, of a number and 4 is, so that's going to be an equal sign, 20. Okay, so let me go ahead and write this out. I'm writing it above the word translate. So 3 times the sum of a number and 4. So that sounds like it would be inside of the parentheses because we're doing the sum of a number and 4, but we're doing all of this 3 times is 20. And there we go. Translate 9 subtracted from twice a number is 7. Okay, subtracted from and also less than are those switch words. I know other teachers may call it something different. Red flag words also work, but you know that you're going to have to move that to the back. So the -9 is going to have to be in the back. Twice a number, so I know that I'm going to need to have 2x, and then here it says equal to 7. So let me add that -9 in before the equal sign. So I have 2x minus 9 equals 7. Okay, so here we're going to simplify. We need to distribute and then combine like terms. In algebra, we like improper fractions. We do not need to change them to mixed numbers. We do not need to change them to decimals. We want to leave them as they are. I'm going to teach you a little trick on how to multiply fractions by whole numbers. Okay, so whatever number is in the denominator. So first I'm going to distribute this 3 halves to the 10. So I'm going to look at my denominator and ask myself how many 2's go into 10. Well, 5 2's go into 10. Okay, then now I'm going to look at the numerator and I'm going to do 3 times 5, that number that I just got, and I get 15. Okay, so now that is what 3 halves times 10 is. It's 15, and I need to make sure that I put that V behind it. Okay, so I have 15V. I can do the same thing with the -4. Okay, so let me ask myself, and I'm going to use green this time, how many 2's go into -4? Well, let's think about it. This may sound a little confusing because it's a negative, but don't worry about that quite yet. Just think about how many 2's go into 4 and 2 2's go into 4. Okay, so now I'm going to use my yellow and I'm going to multiply that 2 by that numerator, which is 3. So that means that I have 6. Okay, so because 2 times 3 gives me 6. And now I'm going to bring this subtraction sign down. Okay, let me bring everything else down. I know this is just a little messy, that's okay. So now we're going to combine like terms. I'm going to use my highlighter. So in red, I'm going to highlight the V's. You need to make sure that you highlight the sign in front of it as well. And then in green, I'm going to highlight my constants. Okay, when I combine these, now I'm going to write up in the top right hand corner 15V and -8V. What I get is 7V, and then when I have -6 and a +6, and when it's +7, and when I combine them, I get +1. So my final answer is 7V plus 1. Simplify 12 plus 4A minus 9B plus 3B minus 15A. So the first thing I'm going to do is I'm going to highlight my like terms. So I see A a lot. You want to make sure that you also highlight what is the sign that is in front of it too. So positive 4A and negative 15A. And then let's go ahead and highlight the B's. So negative 9B and positive 3B. And then we only have one constant, and that is 12. It's going to be green. So when we are writing this in proper form, we want to make sure that if we have any variables, we write those first. And we also want to make sure that we start off with the variable that is first in the alphabet. So first I'm going to work with my A's. So I have a positive 4A and a negative 15A. When I combine those like terms, I get negative 11A. Okay, now I have my B's. So negative 9B plus 3B. So when I do that, I get negative 6B. And then lastly, I have my constant, and it is secretively a positive. Okay, so I'm going to put plus 12 since it's positive. And there we go. That's my most simplified version. So negative 11A minus 6B. I know those look kind of similar. Plus 12. Evaluate when m equals 7 and n equals -4. So here we need to plug in the values of m and n and then simplify. So the first thing that you should have done is just filled in this expression with those values for those variables. Okay, so I'm going to do that here up at the top. So I have my radical sign, and then under my radical sign I have 9, and then times 7 plus 1, and then outside the radical sign I have -4 squared plus 5 times 7. Okay, so there's a lot of stuff going on under my radical sign, so it's kind of like grouped together. So that's what I'm going to deal with first. and I'm going to do this in blue. And so at first I have 9 times 7, which is going to give me 63, plus 1 gives me 64. So I have 64 under my radical sign. Okay, and then I'm just going to go ahead and write everything else down that's in my expression. Okay, so now I need to deal with my exponents. The square root is going to fall under that category of exponents. I'm going to write this now in green. Okay, so the square root of 64 gives me 8. And then I'm going to copy down this minus sign, and then now I'm doing negative 4 squared. A negative times a negative gives me a positive, and so 4 times 4 gives me 16. And then I'm going to just go ahead and copy everything else down. We're doing this step by step by step to make sure that you do it correctly. All right, so now I'm going to write over here in red next to what is in blue. So I need to do the 5 times 7. When I do that, I get 35. I'm writing everything else that I have down because I'm doing this step by step. So now I do 8 minus 16, that's going to give me negative 8 plus 35. And so what I get as my final answer is 27. In order to simplify this one, I need to work in the parentheses first. So in blue, I'm going to copy everything that I have down, but work in the parentheses first. So I have 2 to the 5th power minus, and then I'm going to do the square root of 100, which is 10, and then go ahead and put that subtraction sign and do 4 squared, which is 16. Just ignore that little dot and then put the squared after the parentheses end. Okay, I still need to work in those parentheses, so I have 10 minus 16, so write everything else that's outside of the parentheses. So I'm doing this in red. 2 to the 5th power, I know that's pretty ugly, minus, and then 10 minus 16 gives you negative 6, and then squared. All right, so now I'm going to move down and I'm going to be in green. Okay, so I need to do my exponents. So 2 to the 5th power gives me 32 minus, and then negative 6 squared is going to give me positive 36. Okay, so now all that I need to do is do 32 minus 36, and my answer is negative 4. This one is asking which property justifies the statement below. As you can see, what is on one side of the equal sign is in the same order as the other side of the equal sign. However, we do have our parentheses moving, and it looks like right outside of the parentheses we have an addition symbol. So in this case, the property that we're using is the associative property of addition. Which property justifies the statement below? So for this one, we change order on either side on this from going from one side of the equal sign to the other. So change order, this is commutative. And then I want you to look at what is changing order and what is in between what's changing order. So we have a multiplication symbol. So this is the commutative property of multiplication. And don't forget to add that of in there. When you see pi, I want you to think irrational. You can still plug this into your calculator if you would like to. So do 2 times and then use the pi symbol. And when you do that, you're going to get 6.2831853, and it just keeps going on in your calculator. And since it keeps going on and it has no pattern, it's irrational. All right, guys, so this concludes our review. Please reach out to your teacher if you have any additional questions, rewatch the video, and go over the spots and the skills that you missed. Good luck on the test, and thanks for watching this video.